Managing digital experience applications is quite the balancing act. Between providing the freedom and flexibility to create amazing experiences for your users and still maintaining control of your growing fleet of sites and applications. Achieve that perfect balance with Platform.sh. Platform.sh is a cloud-based end-to-end platform that enables you to efficiently build, host, scale, and secure sites and applications without worrying about infrastructure, whether it's 10 sites or 10,000. Because when infrastructure and workflows are taken care of, teams are free to focus more on what really matters. Everything you need to power your sites is available from the start and then maintained, hosted, and secured by Platform.sh. Databases and other services can be easily implemented into your sites with just a line of code, letting you launch faster. Instant cloning creates perfect production replicas in moments. Developers can work and test in parallel across an unlimited number of environments and then merge with production flawlessly and fearlessly. Plus, code can be written in whatever programming language works for your teams, making code more flexible and future-proof. And without traditional bottlenecks to deal with, every update can be deployed with complete confidence, anytime, anywhere, across your entire fleet. Yes, even on Fridays. Freedom and control balanced together in one platform. Learn more and try for free at platform.sh.
Hello, everybody. My name is Otavio Santana. I'm here one more Deploy Friday from Platform.sh because every day is a day to deploy your application in the cloud. I'm here with Shad. Hello, Shad. How are you?
Doing well, Otavio. Hey, everyone.
Hello. Today we're gonna talk about Elasticsearch, and we have two amazing experts about Elasticsearch. First, hello, Jay Miller. How are you?
I'm doing good. How's everybody doing?
Okay, right now I have a good friend and Brazilian friend as well. Hello, Ricardo. How are you?
Hey, Otavio, Shad, Jay. Nice to be here.
Okay. This episode right now we have a new intro video. Please let me know if you enjoy that because this is a community from community, right? So please put your comment here. I'm glad to hear. And let's start because usually when you talk about Elasticsearch, we heard about Logstash and Kibana. And my first question is how did these work together? And sorry, go ahead.
Can I make a question about the video first? Like, is it possible to use Platform.sh to deploy in a non-Friday, like Tuesday?
Yes.
Just not quite as fun.
Okay.
It's not fun.
There's no
I usually
thrill.
prefer Friday. Yes.
Is there a time limit like Friday at 4:58 p.m.? Like that's the best time to deploy?
More points than at 4:50.
I love this
Oh,
time.
nice.
Who cares about weekend, right?
No. Do you even sleep? All
So
right, cool.
you asked how does Elasticsearch kind of work in tandem with Kibana and Logstash and Beats, and honestly, it's an entire platform. I mean, it is the Elastic Stack. That is a bunch of pieces that make up a whole product. Elasticsearch is kind of the oldest, the original idea of, hey, let's make search easy, let's make search fast, let's make search reliable, and then let's do the same thing for all of the other things that we do around search, whether it's ingesting data with Logstash or Beats now, whether it's taking that data and visualizing it with Kibana. And it allowed us to shore up and make our entire search experience, from getting data to finding data on the fly to looking back at data over a period of time, all of those things fast and reliable and relatively easy.
So what does the experience look like if somebody's going to be using Kibana? I mean, we can deploy Kibana on platform to work with our existing Elasticsearch service. What kind of data am I going to be looking at, or how customizable is that experience for somebody?
So Kibana is basically, we like to call it Kibana is the UI layer for Elasticsearch, right? So everything, Kibana itself has a very stateless architecture. There's nothing actually stored on Kibana. Everything is actually underneath on Elasticsearch. So pretty much all the required indices for Kibana rely on Elasticsearch. In terms of compatibility, the both of them are always has been like using the same release versioning. So every time people release Kibana, usually there is also along with the Elasticsearch. So like the question you made, like, okay, I have a version here running on my laptop about Kibana. So can I use like newer versions or older version of Elasticsearch? Probably this is going to fit well, right? Unless, of course, there's only one exception to this story, which is the famous 6.8 release, where we had this concept of types in Elasticsearch, and then that was the acronym for being like, okay, this is your table, right? And then we got rid of this, right? There's no types anymore. Everything is now an index. So unless if you're dealing with older indices that still rely on the concept of types, you should have no problems doing that. So, and making them work together is pretty easy. Like you go in Kibana, go there to the YAML file, say where your Elasticsearch servers are running, and then they have been designed to know how to talk to each other. Just like I can easily talk with Otavio in Portuguese, Spanish, drunk, whatever. It's on the core.
Please don't do any of those things. My Portuguese is very limited.
As is mine.
So you can choose the drunk option. It's Friday, right?
I mean, I'm in San Diego. Like, I think my Spanish is probably stronger than my Portuguese.
Okay, if you know Spanish, you are almost there to Portuguese.
I don't know. I've been working on it. It's getting there. I was telling Ricardo the other day, like, it's some of the same headaches that I had with learning Spanish I have with Portuguese as well. Kind of the different verbalizations of nouns and like how you would turn, like, or actually not even that, just how you would use verbs in both the masculine and feminine kind of form. So it's definitely a challenge, and Duolingo is not friendly to me right now.
Okay, you let me a good question, because you talk about language, right? We have English, we have Italian, we have Spanish, we have Portuguese as well. How does the internationalization at Elasticsearch works? I mean, how can I put a text in Portuguese and English? How can I make sure that everybody can insert that information? How can I define that?
You know, I'd have to do a deeper dive in that. There are a few ways. I know that our blog, we do a lot of localization and nationalization of our text. And a lot of that is, you know, Elasticsearch doesn't care about the data that you give it as long as it's searchable. So, I mean, if you're giving it UTF-8 data, if you're giving it anything that can, you know, that would be typed and sent to it, then it should be able to find it. I think there might be some questions on how you would structure that inside of your data store, but to my knowledge, I think the easiest way to do that would be to have a English variant and have, you know, a Portuguese variant, and make it so that when you search for one, you get the results for all.
Yep.
Good to know.
And you can define all of this on the, so let me take one step back here just to set a context. Behind every index, you optionally can define what we call mappings, right? Which is the closest definition to what we have outside, in other words, in the database world, like schemas, right? And on the mapping side, you can define what we call tokenizers. And Elasticsearch comes like built in with a lot of tokenizers for different languages, as well as you can plug your own one, like the joke we have in Brazil, like Otavio, like, okay, there's two types of language we speak here. Like, there is the right Portuguese and the wrong Portuguese. So maybe you could like plug your own implementation of the wrong Portuguese, which is basically the slangs and all of that. So TLDR, there's a way, a pluggable way for you to actually specify how to deal with multiple languages. And you do this in the mappings of the index.
Okay, and we have one question for the audience. So how's the best way to ingest data into Elasticsearch?
Oh man, that's like the $1 million question right there. There are
Exactly.
so many ways. Like all right, so I guess I will answer that question with another question. Actually, with another few questions. One, what does the data look like? Two, does the data need to be worked on prior to ingesting it into Elasticsearch? Three, are you using it in some type of programming language? How are you getting this data in the first place? I tend to live in the Python world where, we have a bunch of different clients that are maintained by the Elastic team. They're still open source, so people are able to go in, see how they work. They can contribute to them. I made my first open source contribution on an Elasticsearch client, so that was kind of cool. But I think that it's hard to answer the question of what's the best way, because honestly, the situation varies. If you're working with a bunch of Python data or you're using Python, we've got 3 great tools that allow you to index Python data, whether it's coming from JSON, whether it's coming from kind of the ORM structure that would come out of like another database, or whether you're dealing with a data frame such as pandas or NumPy, that type of data. Then we have something like Elant that you can use. And we have those options for a variety of languages, JavaScript, Golang, to name a few. Ruby, I think, is another good one. So if you just have raw data and you don't have all of that stuff already set up, then we have tools like Logstash and Beats, which allows you to build a simple kind of definition for how your data looks, how often it should be indexed, and any type of mutations that need to be made on the way in, and then also where you want to store it as it's going out. And then it kind of just runs. I've used this before to pull RSS feeds. I've used it to pull government data, just that's publicly available. So I think that honestly, you have to look at your architecture and decide what's going to be the easiest for me to maintain, whether I'm controlling my ingestion from within my project, or if I'm going to add a layer onto it to kind of keep it separated from the rest of the project.
And on top of that, I would like to add that there is a kind of a general misconception in the industry right now that probably became when the acronym LLK became so famous, right? Which is the acronym that has been used to refer to the Elastic Stack. And the misconception is that you do need to actually use Logstash no matter what in order to move data to Elasticsearch. This is wrong in so many ways, right? This is not true. So this is important to highlight because many people kind of live the LOK, the Elasticsearch away because they complain that it's too complex. And just like Jay explained it, sometimes complexity we bring to ourselves, right? Like, okay, so you're dealing here with a CSV file that's not very complex. There is no even master detail relationship. You just need to ship this data into Elasticsearch directly. So why you're putting here Logstash? You don't need it. You're not enriching the data. You're not changing the data. You don't need any custom pipeline processor to like handle that data. So you see what I'm saying? Like sometimes I think that's a developer thing, right? We have this need to overcomplicate things a lot. So TLDR, the point is, there's a bunch of ways to you move data directly to Elasticsearch. Logstash is great, but not necessarily a silver bullet for all the use cases.
That makes sense. Is it possible that there would be a similar case on the other side where Kibana would be sort of an overkill situation, or do you guys just all around see it as there's probably more to your data than you initially thought, and at least gives you that tool to inspect it if you really need to or would like to?
I think in terms of, are you asking using Kibana for ingesting data or just visualizing it?
Just for visualizing, I'm just trying to use the example of Logstash maybe being ill-suited for the type of data you're trying to get into Elasticsearch, that if people do have some kind of opinion, like you said, Ricardo, that things get a little too complicated, they're focusing on Kibana when they might not need it either.
I would say that if you're trying to optimize your systems and one less service that you never use is there, then by all means, you don't need Kibana to use Elasticsearch. You know, the two can be separated.
Mhm.
I will say that I have not really found any situation where running Kibana has given me any issues. Mostly in that, again, Kibana is just a UI layer on top of Elasticsearch data. So running Kibana means you might have a couple of indexes that you'll never use for yourself, but Kibana is going to be relying on it to function properly. But the features that Kibana offer, I mean, sure, if you never want to visualize your data, if you never want like a quick way to search and just make sure the data is available, if you want to just type it into the API, or you can do those things. I've often just seen Kibana as we've kind of cut a lot of complication out so that you can get what you need or find what you need, make sure that it's there. If you need index management, if you need to create index patterns and see what those index patterns are going to look like, that's where Kibana starts to get really powerful, because now you can, from there, you can start looking at how do I structure my data differently. One might say, I'm going to put all of my data in a single Elasticsearch data store and then just find it all off of that one data store. Well, obviously that's great, but there could be some scaling problems there. Once you start getting to terabytes of data, that becomes kind of a headache.
Mhm.
But that's where you're able to start segmenting and using shards effectively and start using different indexes for segmented data. That way you get some different performance perks from that. You also are able to visually think of how is this data different. I just did a presentation showcasing how you can index like US government publicly available data into Elasticsearch relatively easily. Well, the thing is, every major metropolitan city in the US should have this data. So I have a few options there. I could just dump all the data in, and then I have to put all of the different like zip codes and everything else in there, or I can create several indexes based on the locations, based on the state, based on the region, and then kind of use that as a way to segment data. So I can say like, okay, US data West for everyone that is probably going to be looking for data from the West Coast can sit here, and that can have its own indexes, versus US data East, instead of having to look at one data store and then try to splinter that out and say, okay, do a search for only this data in this area and make things way more complicated. So I think, again, it's like all of that to say, like, you don't need Kibana. Kibana helps you to visualize your data, but it also sets you up to start thinking about how you should set up your data so that it is easier to visualize and it's easier to work with.
That makes sense. Would the cycle of something like site search allow me to do something similar, of getting feedback of the queries that are being placed on my index, just purely a search bar, simplest case inside my website? Is this where we're going to start seeing some of these visualization advantages of what queries are being placed and how results are being given?
I would say that this is not, yes, the answer is yes, but I would say that this is not necessarily a characteristic of using Kibana. It's more like a characteristic of how do you extract data from Elasticsearch.
Mhm.
So let me explain this like differently and easily. There, we like to joke that, at least I like to joke, right? That there's two types of developers and users, right? The ones that love CLIs and the ones that actually like to do everything on a UI-driven approach, right? Which is essentially what we're talking here about Kibana.
Mhm.
So the information that the example that you just gave about, all right, how do I see, or is there ways to see like where are the optimizations or maybe the relevancies for certain queries that I'm implementing here on top of Elasticsearch. So there is a way to actually retrieve this information using the CLI. Actually, more importantly, there's ways to do this using REST, right? Because as you may know, everything in Elasticsearch is an REST API. So you can have a curl command that basically queries and fetches the optimization engine behind Elastic Query, where you can learn about, okay, so I should tune here this knob to improve the efficiency of this, the relevancy of this query specifically, right? So I would say that, just like Jay explained it before, you don't actually need Kibana for this, but if you do use Kibana, your life's gonna be way, way easier.
There's a pretty specific question in chat. What concerns do we need to have when ingesting data from JDBC sources using Logstash? One, that's a great question. It's always good to be thinking about how am I going to break this? That tends to be my my standard of operating is, and that's why when you say Platform.sh allows you to deploy on Friday, I'm like, no, just no. I will find a way to break it. Don't worry. From what I can tell, and I'm pulling this straight from our docs. One, we have a plugin for Logstash for JDBC operators. So if you're using Logstash and you're trying to do it kind of I brought my hammer, I brought my chisel, let's get this data in here kind of platform, I would highly suggest looking at the plugin. And I can't seem to find a way to add it to the chat, but what I'll do is I'll add the link into our chat. That way, if somehow we're able to get that out there, that would be great.
I would I would highlight the fact that in terms of problems, because Antonio, he should be Brazilian with that name, Antonio Carlos da Silva. I think in terms of problems, one of them would be okay, what the JDBC driver connector for Logstash actually does, it pulls the database, right? So it doesn't actually read the data from the log level of the database. So you're basically pulling the data periodically to retrieve the data. So one of the possible problems, you might as well down the database, right? Because you're computing transactions with the IO transactions that the database is handled concurrently. So this is one. Secondly, and this is more specific to Logstash, when you read a record from a database and that record is read from the input on Logstash, everything up to that point is in memory, right? So Logstash has this very layered architecture where you have inputs, you have the processors, and you have the outputs, right? Each one of them are basically and essentially running in memory. So if one of the nodes that is just got at the record from the database fails and it didn't even started the phase of the processing part, one of the problems, you might lose that record. So if you are dealing with a scenario where consistency and integrity means a lot, you should actually turn a feature called persistency on Logstash on, because that ensures that on each one of those layers, you're never going to lose. It's not that you're never going to lose. It always has a possibility of losing in distributed systems, right? But you will minimize a lot the possibility of that happening, because the persistent capability actually persists the data on disk on Logstash. And then if one of the nodes fails, the next layer can actually picks it up from the disk and continue the processing. So I think the problem here is there will be a bunch of other knobs that you have to switch on in order to ensure consistency, right? Because that's a misconception about the JDBC driver, right? Every time people say, yeah, I have a JDBC driver, so everybody thinks, oh yeah, so it's JTA compliant, so we can have distributed and global transactions in place, so consistency won't be a problem. Not true, because Logstash, and here's the bummer, Logstash doesn't enlist itself in the global transaction. So there will be two different transactions. So consistency problems may rise.
Okay, let's hold back a little bit about the Elasticsearch approach. because I saw a good question about here because a lot of people are asking the relationship between Apache Lucene and Elasticsearch.
Oh, okay. Do you want me to take this one, Jay, or should you want?
All you.
Go to the origins.
Okay. Okay. So yeah. So underneath, Elasticsearch is all about Lucene, right? Apache Lucene, which is a framework, is a Java framework to implement searching capabilities. But what Apache Lucene doesn't offer you is the ability to handle the ability to actually handle scenarios that a typical distributed system would handle, such as fault tolerance, horizontal scalability, right? Some certain aspects regarding security if you're running on multiple in a cluster with multiple nodes. This is exactly what Elasticsearch does and does very well. So it basically like augments Apache Lucene to deliver that, right? So we like to say that Elasticsearch is basically Lucene on asteroids, right? Basically, that's what Elasticsearch does. Technically speaking, right? So there's that's the context. Technically speaking, there's a relationship between them, right? So Elasticsearch is a cluster-aware technology, right? So that means that you can run Elasticsearch over multiple nodes, and those multiple nodes are going to form a cluster. Like, so point number one, when you create an index, when you index a document on Elasticsearch, you can specify if that document is going to be like how many shards that document is going to have, right? So in other words, it's like you say, okay, I want to break down all the documents into multiple nodes in a cluster instead of relying all the documents in a single node, which is not very fault tolerant, right? By the time you create multiple shards in an Elasticsearch cluster, you are actually, technically, in the end of the day, you are creating many small Apache Lucene deployments on each one of the nodes. So what is a shard in Elasticsearch? Is essentially a full-flatted Apache Lucene deployment, right? So that's the relationship between Lucene and Elasticsearch.
Good, Dion. Because Elasticsearch is a search engine, right? So famous. However, I saw some information about there are people who are using Elasticsearch as a database, as NoSQL database. Is that possible? Is that right way?
I will do this. I will say if it's possible, and I will defer if it's right or wrong to Jay.
Oh, that's
So
thank
I'll
you.
put him in a spot.
You're gonna get me yelled at on the internet. Awesome. I will say that I have run projects entirely on Elasticsearch. However, I might be a little biased, but I think that deciding to use Elasticsearch as your primary data store for loading and manipulating and editing and working with data is absolutely possible. Is it always the right decision? I mean, is any database ever always the right decision? I think a lot of that does come back to, exactly what are you trying to do? One of the things that an Elastic cluster has to do is it has to go through this process of almost making sure that it's more reliable. So when you load data in, you're going to have your main node. If you're practicing any type of redundancy, you're going to have some backup nodes. You're going to have things having to communicate with one another. And the way that Elastic is able to be as fast as it is that it's going to recruit as many services as possible to get you that data, which means there might be moments of time where you're still getting that data situated and trying to load it at the same time. And if you're doing that, there might be some inconsistencies. Now, again, if you're just presenting data, again, a lot of what I do with demos and a lot of what I do with some of the smaller projects that I've worked on is I have data. That data doesn't change very often, but yet people spend a lot more time finding and loading that data up than I spend actually writing it and adding to it. I think that's where, in my opinion, Elasticsearch is one of the best ways to store your data, because if you're using it, use it. If it's already there, if you're already applying it, you don't need to add some added complexity of now let's take my, you know, my SQL database, let's pull everything out of it, let's go and add it to our Elasticsearch cluster so that it's searchable, and then let's just keep repeating that process over and over and over and over again. Whereas if I can, every time I make a change, just have it store whenever I'm pulling up a document to say, okay, from this index, load this document. If I'm saying, hey, even searching for a single document, as long as you're within a scalable range, can be extremely reliable and take minutes to get connected. So now you have your search and your data layers done in a matter of minutes versus having to build out a SQL database or a Mongo database. Nothing wrong with those. I mean, sometimes you need those things. And then saying, now let me connect those to my Elasticsearch instance. And then now I have two things that I got to maintain, and then no one's having fun.
Yeah, well, I would just add that if you plan to use Elasticsearch as your data store, just like as if you're planning to use any database technology as your data store, I think the only thing you have to be aware of is the consequences of, which has to do with understanding the technology specifically, right? For example, just one very easy example, Elasticsearch doesn't support transactions, right? So if you're deeply interested on handling transactions, don't go with Elasticsearch, because Elasticsearch doesn't support it and probably never will. Another thing is, and probably this is more to do with specific use cases, right? Which has to do with how do you model your data, right? So one of the things that developers find very like, it's not that it's not possible in Elasticsearch, but it feels wrong when you're doing it, is when you have a use case that requires establishing multiple relationships between your documents, right? So let's take one very example, like the master detail relationship, right? I have an order that has many items, and each item might be associated with a product, right? Can you implement this use case in Elasticsearch? Yeah, definitely. It's doable, technically speaking. Is it easy? No. It requires you to pre-think your design, pre-think how you're going to leverage this master detail relationship to make sure that all the documents will end up in the same shard, which in turn has to do with how we're going to identify uniquely your document. So there's a whole lot of complications that when we say, yeah, can we use Elasticsearch to store data as my data store? Yeah, definitely, I can use it. And this is usually happens when we are back in the rational unified process days, like in the past. We used to call this the inception phase, right? When we were planning the architecture. But by the time we get to the actual development of the application, we find out, this doesn't smell so good. So I think the TLDR here is understand the technology and make sure the technology fits your use case, right?
Yeah, because I think one of the things that you mentioned there with trying to replicate this relational structure on a NoSQL database, I mean, that's not just Elasticsearch. That's going to be any type of NoSQL database that you are working with. And I mean, there are benefits and drawbacks to each. So like Ricardo said, and just to kind of echo that, make sure that just because Elasticsearch is fast doesn't mean that your fingers should be when you're actually writing code. Think about it, take a second, and then say what's going to be the best way to implement this so that I have, redundancy, scalability, all of these things that, a lot of developers get paid to think about. We don't get paid to write code. We get paid to not write code. So if we're having to write stuff to support things that we're adding just because we think that it's, our opinion that we should do it one way versus another, I don't know if we're doing our jobs right. Shots fired. Uh-oh, we lost one.
Otavio. He wasn't for that.
Otavio was like, how dare he?
So Jay, I forgot to mention that Otavio is the NoSQL guy in Brazil.
That's fine. I absolutely love. So prior to working at Elastic, I was a big MongoDB user. So that was kind of my thing, was that was wedge the MongoDB database into whatever project I needed, and oh, you need 15 relationships. No, you just need 15 MongoDB instances. Like, you don't need any of this. So I'm right there with you. But like I said, I think a lot of that is being comfortable and knowing when your tool is the right and when it's not the right, tool for the job.
Yeah, I totally agree with you. I mean, when you choose any kind of NoSQL database, you need to understand that it's a time to say goodbye to normalization thing, right? So this normalization become your friend, and that might be a nightmare.
Yep.
In some case. We as a developer, we are always looking for some silver bullet solution, but there's not, unfortunately.
Yep. That's true.
Also, you talk about database. Does Elasticsearch support aggregations?
Yeah, it does. Actually, the support for aggregations in Elasticsearch is quite powerful. In a lot of ways. The first of all, because it allows different contexts to request and execute aggregations. And by context, I mean you can do this over different programming languages. Obviously, Java, Go, Python, C#, C++, .NET is one. You can do the same with REST. You can do the same with CLIs. And obviously, you can do the same with Kibana. Arguably, that's what Kibana does best, right? Which is basically create sharp diagrams and visualizations that ultimately are basically issuing aggregation commands into Elasticsearch, right? So yeah, that's possible. The other thing that I find interesting is that there's some very built-in support for custom aggregations that you can build in Elasticsearch. And what that means is that you can, let's say that I would like to create. Let's start with the user use case, right? And then we go through the implementation details. Let's say that I want to create this pizza graph where that each slice of the pizza is going to represent a something for each state in US, right? But I would like to actually, by the time I click in one of those slices, I would like to drill down into that state and see the information about the cities. Look, this is the arena where, for those of you that came from the BI background, business intelligence, you're creating what we used to call the table fact and the dimensions, right? So that's the type of thing that you can implement in Elasticsearch. You can have a fact table. It's not a table, right, technically, but you can have a fact document and have the dimensions related to it, everything specified in one single aggregation that, once executed, will return everything that you need to actually materialize your pizza chart. So that is quite powerful in Elasticsearch. Is that your question?
We got a question actually from the audience again from Antonio. Sorry, pulling the mouth. What about Elasticsearch as a resource for CQRS architecture standard for query? Did you know some use case for it and other resource for command approach?
I wouldn't say that there are resources for this, but I'm going to make an analogy here because I came from the Kafka background, right? So it is just like Kafka. There's obviously no resources or features in there, but you can implement, CQRS command patterns as well as event sourcing in general using Kafka, right? Because those, in the end of the day, those are more like design patterns than actually technologies or features that you're going to leverage. So all boils down to implementation model. So objectively answer your question, Antonio. So can you implement CQRS with Elasticsearch? Yeah, you can do it. You can use the first step would be obviously treat your documents store in a durable way within Elasticsearch and spread over the charts. And your, let's call CQRS processor, which would be a component in your programming language that would periodically read the documents, right, and rematerialize the state of a given table or index, right? So your end user applications or end user processors or downstream processors could read from it, right? So yeah, it's possible. But there's no like, okay, yeah, there's a feature on version 7.10 that actually, no, there's no feature. It's more like there's an implementation effort that comes with it.
Nice. I have one more question about database. It's more about the challenge to shard everything. Is there any suggestion, ideas, pitfalls to make that sharding possible on the easy way? When should I shard my database? How and why?
I'll take a bet on the question, and then Jay, can you help me explore further? But let me start with the last one, Otavio, like how, right? No, actually before last one, the why. Sharding is something that you would do because you want to horizontally scale your cluster. That's basically the motivation that developers would take for, okay, do I need actually to implement shards in my cluster? So that means that you are intrinsically interested in some specific feature, which is I don't want to have any single point of failure in my architecture. So that's why I will need to rely on multiple nodes to create replicas, right? And the very own concept of shards and replicas and Elasticsearch are different by definition. So you can have a shard because what we call primary shards, right? Because I'm going to break down a set of documents and spread them over multiple nodes, and therefore I will achieve horizontal scalability. So this is more about offloading the overall performance of each node, right? Divide to conquer, if you will. But the concept of replicas has to do with another thing, because let's say that you have a node, and that node is running like multiple replicas from a given chart, right? So those are not entirely passive entities that are just sitting there for backup purposes, right? Those backups are actually being used somehow. For example, when a developer issue a command for any given node that is going to search for that specific document, all the cluster can rewrite that for a node that has a backup and serve that request from the backup, right? Which is pretty cool if you think about it, because that means that the other nodes that are so busy with I/O won't have to actually use their compute resources for serving that request. So it's another way to actually scale out your architecture, right? So I would say that, yeah, primarily you're looking for scalability and fault tolerance for using shard. That's the why. Now, the complicated part, I would defer to Jay.
In terms of like creating your own sharding strategy, I added another link into our chat there. One of the things that we have to remember with sharding is that there's overhead that comes with it, and this document talks a lot about that.
Yeah.
You can have as many shards as you want, but should you? That's another question. There's a lot that can happen in terms of just wasting resources. Our written guidelines are aim for shard sizes between 10 and 50 gigs, and then aim for 20 shards or fewer per gigabyte of heap memory. So that's kind of our overall like guidance in like, should I shard? How should I shard? A lot of it's going to be determined based on your server architecture and like just how many resources are available to you. Like Ricardo said, having several nodes that are kind of operating in tandem, having nodes that are doing their own dedicated thing. You have one that's just taking in data and processing it and sending it out to the other nodes and giving it all of the instructions needed to operate, allows you to segment your data so that maybe you do have a little bit of a faster response when it comes to your search optimization or even your ingest optimization. But again, at what cost? And I think that that's going to be the biggest indicator of, can you? Yes. Should you? A lot of it's just going to depend. What are your resources? Don't do this on a Friday and then leave and expect everything to be great, unless you're using Platform.sh, I guess, and then you're good. But
And there's also a tricky, now this is for all the Java developers that are watching us, right? There's a tricky thing that Apache Lucene does. Like, remember the explanation that I gave about shards before? Like, on each shard, you basically have a full Apache Lucene deployment on that shard, right? A whole instance of Apache Lucene. In the code of Apache Lucene, basically what it does is to retrieve the compute power by running runtime.getRuntime.available processors, right? So essentially, on that machine that, let's say, has only 2 cores, right? So one instance of Apache Lucene is already leveraging those 2 cores, right? If you put another shard in the same node, that another shard will actually still try to leverage the 2 cores. How do we call this? Back to the computing classes, like for years ago, we call this context switching. That's what explained when you were, even without any load in your cluster, you see that the CPU uses like 60% or 70%, and you can't understand why. So, like Jay said, creating shards is cool, but has a cost, right?
All the cool kids
Okay.
create shards.
I have one more polemic question right now, because I read several articles, no official one, but several tips about how to use Elasticsearch. And usually they said, instead of update any data, remove and then insert again.
Oh.
My question is there any issue with update in Elasticsearch?
Can I say yes and no would be an acceptable question?
I was going to say, I do it all the time. So, like,
but it depends. It depends. So let me put it this way. So yeah, first of all, there's a mantra, right, that started like in previous releases of Elasticsearch, where there would be no update API yet available, right? So some of the blogs and some of the articles out there kind of leverage this old version, saying, yeah, Elasticsearch doesn't support updates, which is no longer true, at least for the update API part. All right. So this is one thing. So 7.10, you have an update API. That's the first thing. But the part that is actually not true about this is that Elasticsearch never actually supported updates. This is also not true, right? In order to explain this, I need to explain how updates occur in Elasticsearch, right? Probably going to take a minute, so bear with me, right? So documents in Elasticsearch are immutable, right? It means that once you store a document, 2 things are going to happen, right? Not necessarily concurrently, but conceptually concurrently. Indexing process is going to take place, which entails to like update the inverted indices that actually make the searching so fast, as well as the actual storage, routing and storage of the document into a given shard, right? Because there is this indexing phase, right? You cannot simply go there to a document and update, right? Because if you simply update, oh, how hard can it be? Just update one of the fields. It is very hard, because that would need to trigger a re-indexing request to whatever the document has been stored, right? So technically what happens when you issue a update API request is step number 1. The document, the old, let's call old document, is marked as deleted, right? That's step number 1. Step number 2, a new document created out of the previous version is created with the new or multiple fields updated, right? Step number 3, this new document that is generated is re-indexed within the cluster. And step number 4, there is a set of a pool of background threads on Elasticsearch that keeps, it's like the mark and sweep algorithm of JVM garbage collectors. Like, so there's a background process that actually keeps sweeping all the marked deleted documents. So as you can see here, it's not so trivial to actually just update the document, right? So for anyone that actually issue a update API, is going to look like that. Yeah, it's just an update, but everything is happening behind the scenes. And what this has to do with you if you're dealing with a scenario that relies on consistency, right, you might have a lot of surprise, my friend.
And again, we think of these as trade-offs for what we do best, which is search. So being able to consistently find the data that you're looking for means that we have to make sure that that data is available until we know for a fact that it shouldn't be.
Right.
And that's where, again, we've hounded this before. A lot of planning should go into place before we start making decisions on like updating data versus re-indexing. Like, what's our plan with this? Like, are we doing this at night when our traffic is low, searches are low, calling queries are low? So like we're not necessarily taxing our systems as much. Are we doing this? Are people using these systems around the clock 24/7? They're constantly being pulled. Maybe we don't, pull. Maybe our search data and our actual live like record store do need to be separated in that case. That way we can make those updates as necessary without impacting the entire site, and we let Elasticsearch just handle the search end. A lot of these questions are questions that I think come out of the idea of I just want one thing and I want it to do exactly what I want it to do, exactly how I want it, and how come, NoSQL can't do it, Elasticsearch can't do it, MySQL can't do it. Like, it's like at the end of the don't leave yet, Otavio. I promise. It's going to come out good for us. But but at the end of the day, like if we're not trying to utilize the best tools for the job, again, we're not doing our jobs right. And I think that's where if you're running into a question of should I re-index this versus updating it, I think the right question is what is going to be the disadvantage in my architecture if I do decide to update this versus re-indexing it. Not necessarily should I. Should I? Sure, why not? Can I? Absolutely. Is it going to affect my system in some way that I need to be prepared to explain to my boss when it's Friday and I've used Platform.sh to make migrations and things are happening as expected? I can't answer that question. I can only tell you that Platform.sh will allow you to deploy on Friday, and you'll be happy that you did.
What do you have to try for these pitches? They're just so naturally coming in. We have a question for the audience along the lines of this. So we have a file currently marked as deleted. So what happens if there's a request that's happening during that cycle, but the new version is available, but we haven't cleared out this deleted version either? Is there anything special that happens in that case?
First of all, I know that person, and hi, Karina.
Hi, Karina.
Hi,
Karina.
She's very good. Secondly, Karina, that market document won't be served because by the time a document is marked as deleted, right, something also happens. So any other request that comes in, it's like they are put on a blacklist, right? So they would never be served for any new requests, right? They're there just for eventual deletion, right? So, and if you're asking for the point of view of the client application might take a while to receive the actual request. That's what happens behind the scenes because you keep waiting for the response. Where you can set a timeout in your request to actually put a time for when that happens.
So we're talking about rethinking your approaches to deleting from index, updating from the index, sorry. But just the general principle of like where tools might be the most useful within this whole stack and when they may not be. Is there any examples that you can think of that are just truly impressive use cases of Elasticsearch? I know within specific features I've seen on your website of people using machine learning within Kibana to train for anomaly detection and really become a useful tool for detecting fraud. I don't think that's a pretty specific case, but anything that comes to mind that really impressed either of you?
In terms of being impressive, I think the one use case that always impresses me for Elasticsearch specifically is the GitHub. GitHub, all the code is indexed in Elasticsearch. So if you think about the amount of code that GitHub manages and the amount of searches that happens not even if every single day, every single second, right? I think that proves a little bit about the capability of Elasticsearch to handle scale, right? It's not a coincidence that the technology start with Elastic, right? Now that's the propaganda for the company, right? For Elastic. So yeah, I think that in terms of use cases is this, but the use case that you listed about the machine learning part, this is something that actually is quite new in the Elastic Stack, right? I don't have any more like a how do you say, like more insight about those features. I've never used it myself, but what I can say is, imagine a place where you have all those documents, where you have all this information sitting there waiting to be analyzed. I think that's Elasticsearch makes a very like interesting playground for you to deploy your machine learning algorithms that will somehow like learn with all that data. So I think that's in terms of does it make sense? Yeah, there's a lot if you think about it.
Sure. I'm always curious when you have something open up like that and provide some kind of supervised learning where you can define your classifiers a little bit. But it's always interesting when you have a little bit more hands-off unsupervised that's kind of built into it. I'm just very curious if any of you guys have played around with that, and is it just a continuous discovery type of thing to see what's lying inside of your data just straight in the dashboard there?
I think, and I, to everyone's surprise here, I come from a like non-traditional like marketing background and doing a lot of like marketing and like trying to understand what our web traffic meant. Like, what does it mean when we see these spikes? What does it mean when there are certain categories that are getting more hits than usual? Is it a good thing, or is it because something is inherently wrong in our process? I think one of the funniest conversations I've ever had with an employer is, they said, "Oh, look, we have so many hits on our website," and I said, "But think about it. That means they're having to go to several pages to find all the information that they need. You're a B2B business. You don't care about how many hits. You just want to serve your customer as well as you possibly can." And I think that that's where kind of opening the door to some of the machine learning constructs that we have in place now can really help with that. You can say, let's take log traffic from something like Nginx and compare that to app search data and see, hey, we have a lot of people from one region that are searching for a lot of data, and it seems to only be this region. It seems to only be this one perfect situation that we're not thinking about, because all we see is the number of hits going up, and we're like, oh, this is awesome, we're getting more views. And it's like, well, but are we getting the right views? And I think that that's where the power of search as a whole, kind of like the whole Elastic mantra, is so important, because it's not just making sure that you can find the data, it's making sure you can find the right data, and you can find it in the right context as to how it should be presented.
Okay, GitHub and Elasticsearch. So I'm glad at least somebody can read my code and don't complain about it.
Yeah, exactly.
with no,
we don't have to run it. That's the reason.
No judgment. Okay. We are almost over the time, and I need to do the classic question. When should I not use Elasticsearch?
I'm out. I'm out.
You guys.
Okay, I can help you with that.
Yeah, go ahead. I'd like to hear you. Okay, I'm back. I think I gave one example already, like when we were like discussing, should you use Elasticsearch for your data store? And I gave the example of, yeah, you can. But if you are looking for a highly transactional system that relies on ACID, like atomicity, consistency, isolation, durability, you probably will miss one of those letters there. Yeah, you will have atomicity, you will have isolation, and you have durability, but not consistency. That will be eventual, right? And then, so that's a use case where you should not definitely use Elasticsearch. I think another one that I can think of, and this is purely based on my experience. I don't know that should be like a use case where you should use it or should not use it, but I will explain it the same way, and probably you understand, right? So let's say that you're designing a system that system will basically serve as the master data for a lot of other systems, right? So that means that your objective here is to use a technology that is so powerful, it addresses elasticity and scalability so very well, that becomes an ideal component for you to actually store data there and make sure all the new applications or old applications just go there and take your time and read it the way you do best, right? I would say that that's a use case where you should not use Elasticsearch, right? That's a wrong assumption. Just because Elasticsearch is scalable, it doesn't mean that it will play well with every single use case. That's what you should use Kafka, for example, right? Because Kafka would allow you to, okay, I can consume that data in a batch fashion, I can consume that data in a streaming fashion, and I can consume the data in a real-time fashion, and not necessarily all those like downstream applications will be impacted with each one of your use cases. That would happen with Elasticsearch, right? Because of the whole consistency, updates, the market for deletion discussion that we had. So TLDR, like, just because you can, it's not necessarily you should.
Username and passwords, that's when you should not use Elasticsearch. And I think I only joke about that because there was recently there was a security leak in which the attackers actually left all of their information in an unsecured Elasticsearch database. So they actually were caught because they put all their stuff in Elasticsearch, left it unsecured, and then like didn't do the right things with it. So it's kind of like, I would say, to kind of wrap us up, I am finding more and more ways in which Elasticsearch can work for projects. I mean, I was kind of bullish on the idea of like, oh, well, just be great at search. And then I realized, well, being great at search means that you can be great at a lot of things. And as I'm starting to see more and more of those use cases, as I'm starting to see like, hey, we can take, gigabytes, terabytes of data, manipulate it to make it very searchable, even take data that's going to be held on to for a long time. 7.10 just announced, the ability to search across snapshots. So you now have the ability to take data that's been around for years and years and years, store them in S3, store them in Glacier and things like that. And then when you need to search across those things, you can, and that will save you some performance, that'll save you some cost. And it's like every time I'm hesitant to say that there's a reason when you shouldn't use Elasticsearch, because every time I do, there's like an announcement of some updated feature that's like, well, I take back what I said. Go ahead and use Elasticsearch for that too.
I would say this: try to use Elasticsearch for pretty much everything, and if something goes wrong, blame Jay.
Yeah, and make sure you deploy on Fridays. Using Platform.sh.
With Platform.sh.
Yeah,
we got so many mantras for this one. Thank you, Jay. Thank you, Ricardo. That's going to be it for us on this episode of Deploy Friday. Thank you all for joining us. Thank you, Otavio, for having me on to co-host this with you. Join us next week on the 20th. Oh, I'm sorry, on the 27th. Today's the 20th. We'll be talking a little bit more about Helidon. And thank you all for tuning in. Take care.
Obrigado.
Thank you. See you there.